Today, we will be learning about thinking, reasoning, and language from Chapter 8 of your Intro Psych textbook. And these are really important and interesting topics in psychology, right? A lot of your psychology is about what goes on in your head, in your mind. And that's hard to study, isn't it? It's hard to observe because it's in your head. And that makes it an interesting subject and a fun challenge. Words in psychology are defined in different ways by different researchers. I have taught from different intro psych textbooks, and they will have slightly different definitions of cognition. The definition that is being used in your textbook is this one. They're defining thinking as any mental activity. Like everything mental. According to that definition, well, feelings have mental activity, so feeling is thinking. Any mental activity or processing of information, including learning, remembering, perceiving, communicating, believing, and deciding. This is the broadest definition of thinking I have ever encountered, because it would include that verbal stream of thought that you have. It would involve any other kind of mental processing, say of images, of emotions. Any mental activity or processing of information would involve non-conscious processes. So this is the broadest definition of thinking that I've seen. It's covering basically all the activity of your brain. Anything psychological is also biological. Any mental activity, that's pretty much anything your brain does. Any information processing. Isn't a reflex based on information processing? That's a very broad definition. Then they make the point about efficiency. And the principle here is that your brain, your mind wants to conserve energy and conserve resources. This is just generally a good strategy for living organisms. Your body tries to conserve energy and resources. Well, your mind does too. We seem to have a two-track mind. We have our conscious mind, our conscious awareness, that is capable of complex analytical processing. And then we have a lot of non-conscious processes that go on in parallel, actually. And these may be unspoken. These are automatic, but they do influence our thinking. They do influence our decisions. So we have a lot of, we have our gut feelings, and we have intuitions, and we use heuristics. We have to there's so much information out here that we could process at any given moment. And we can't be thinking carefully about it all. So just to get through a day, we rely on habit a lot. We rely on assumptions. We rely on schemas, which are kind of like assumptions about how things work. And hey, look at us, we're all here. So we get through the day doing that. Though when we rely on those shortcuts, we can be more prone to errors. So those automatic processes can be much more biased. We use shortcuts called heuristics to think or to make decisions more efficiently. And they give you 3 examples here: a representativeness heuristic, the availability heuristic, and then they make a point about hindsight bias, which I don't think is a heuristic. It's a form of bias. But let's talk about them. So if we use the representativeness heuristic, then we're judging the probability of an event by its similarity to a prototype. Prototypes are like stereotypes. I'll give you an example. Let's say you are walking down the street at night in a dark alley and you see somebody behind you. And so you hold your bag closer, you feel fearful, and you walk more quickly. You're making an assumption there that the person behind you has criminal intent. Most people on the streets are not active pickpockets. There's a very low probability that that person actually is out to get you. It's more likely that they're just another person on the street behind you. However, you could see how using that heuristic could be adaptive, because the 1 in 1,000 time that it actually was somebody with criminal intent, maybe, you walked away and got away. So maybe it paid off in some way. The availability heuristic involves estimating the likelihood of an occurrence based on the ease with which it comes to our mind. I'll give you an example. There are many, many fewer airplane crashes than there are motor vehicle accidents. And if you are going to die in some kind of a transportation-related accident, it's probably in a car. And just think about it. Cars are not as well maintained as planes. The operation of an airplane requires a much higher level of qualification. There's a much higher level of oversight and control than, compared to the ease with which people get a driver's license. Right? And there's 2 pilots, but you don't have a co-pilot when you're driving. And your car is definitely not going to be maintained to the standard of the plane. And you're not following a pre-planned schedule, a route, the way that the plane is. And, you don't have radar. So you're much, much more likely to die in a car crash. But there's so many car crashes that the news media doesn't report them that much. However, let's say there's a plane crash. Wow, that's newsworthy, right? Let's talk about it all night. Let's cover it on all the different channels. Let's put it in all the newspapers on the front page. And so the idea of a plane crash is much more available to your mind than its frequency of happening out there. And so you'll get people who are afraid to fly, and so they drive instead. Well, actually, that's probably more dangerous. Humans have many, many cognitive biases in addition to hindsight bias. Hindsight bias is just one of our many biases. I think we talked about other ones in chapter 2 on research methods. Like, we are likely to be overconfident. We're likely to be more confident in our beliefs than we are accurate. We are likely to look for evidence or data that confirms rather than refutes our beliefs, which is what we'll be doing if we are good scientists. And another one is hindsight bias. Once something has already occurred, we feel like we can see why that happened. We're like, oh yeah, I see what was going on. This led to that led to the other thing. It's easy to do that. It's much, much harder to predict the outcome of an action. And this is why when we test theories, when we test hypotheses in science, we make predictions, right, rather than backwards explanations. I felt like the way this information was presented suggested that hindsight bias was a heuristic. It's not. Those are different things. It's a form of bias. Our perceptual system involve both bottom-up processing and top-down processing. Bottom-up processing is when information comes to us from the outside world, right? This my eyes are receiving light that's bouncing off this object, and there's neurons in my brain that are reacting to the shape of the leaves. Okay, and a mental image is being formed of this object. That is bottom-up processing. But it's not the only kind of information processing we do. We also do top-down processing. So what you believe influences what you see. Because of schemas, because of stereotypes, because of expectancies. I'll give you some examples of top-down processing. People who are themselves sexually motivated are more likely to interpret friendly behavior on someone else's part as flirting. There's top-down processing there because there's a pre-existing belief that's being projected onto the other person. Give you another example. There's a famous case where a young man had a lump in his pocket. He ended up being shot. The man who shot him interpreted that lump in the pocket as a gun, when it was actually a bag of Skittles. So there's some top-down processing there, because that the individual who was the shooter, I can't remember if it was a police officer or a security guard, some position like that, had a pre-existing belief that influenced what he saw. And so our top-down processing involves all these things we already know, all these concepts that we've learned, schemas, which are beliefs about the way the world works, or expectancies about the way the world works. Now, this chapter is interesting because they started with the broadest definition of thinking ever. And normally I'm used to teaching with like perceptions and attitudes covered in different chapters. And this chapter is bringing together a lot of these different things. So for instance, we're talking about language and the way it influences thinking. When you think of thinking, that's called metacognition, you're probably thinking about this inner voice in your mind. Is there like a voice that talks? Is your stream of consciousness verbal? If we think of thinking in that way, well, then there's an assumption that thinking depends on language. Interesting. Phoenix says, not for me. So Phoenix, you don't have a verbal kind of inner monologue? I certainly do. Mine is like going on all the time, and sometimes my mouth starts to match what I'm thinking, and then I seem to talk to myself because it's such a verbal experience. So maybe some of us have this verbal inner monologue, and others might think in images. I can't even imagine what that's like, thinking in images. That sounds so alien to me. And Nicholas said, so some people only think in pictures. Well, that's what Phoenix is saying. Cadence does both. So maybe you have an inner voice, or maybe you don't. I certainly have one, and it like talks over me when I'm trying to do things. It can be very irritating. Can be ill-behaved. And Liam said, "Can you not think in pictures?" I do both. I can sometimes, if I'm remembering something, a scene, then I can imagine that setting, and I could think to myself, well, I wonder what would have happened if I had said something differently. Then I might be able to imagine that playing out, but I find that a lot more effortful. And personally, for me, it's like an inner monologue. It's like the radio. And Haley says, Cadence sees vividly. Haley says, I can't see anything at all, no matter how hard I think about it. I remember what something actually looks like, but I actually can't see it. So it sounds like we differ in the ways that we think. You know, some people will have memories in which they see themselves in the memory, as if like somebody was filming the event and they were holding the camera. And then other people will remember it as they saw it through their own eyes. Like, you can't see yourself in reality. So it's interesting how some people's memories add that layer. There was, let's say I believed, because this is my experience, that thinking is verbal. Okay, it's that like inner monologue. Then I might believe that it would be impossible to think without language. But we know that's not true. Think back to that really broad definition of thinking we had. That's like any mental processing. Well, obviously, people who don't have language can do that. Children don't learn language for a few years. Obviously, 1-year-olds, 2-year-olds have something going on upstairs. There are people who, for reasons of deprivation, never learn language. Okay, and they're probably tested as intellectually disabled, but they still process information. They still have mental activity. A child who hasn't learned any words yet can still able to communicate and respond and react to its environment. So obviously that is not true. Okay, you can paralyze somebody's vocal cords. When I think, I often kind of want to mouth it out. But let's say we could paralyze those regions, so I can't be doing that simultaneously. Well, I'd continue to be able to have that inner monologue. I'm looking back at the chat now, and this is interesting. I've never heard this before, but apparently some people can change what voice they hear in their mind or control the volume on it. I can't do that. And I can't turn it off either. It can get very distracting. So Cadence doesn't hear their own voice, but hears like another gendered voice. I remember feeling really surprised the first time I heard my own recorded voice, because it doesn't sound like the voice in my head. It's much more high-pitched. And Liam's inner monologue can be someone else's voice. Can others do that? Fascinating question. I've never heard that. I don't see why you couldn't be able to do that. And it also helps you understand how, maybe if things got a little bit more intense, there are people who hear voices that other people can't hear. And maybe some of the same processing is going on there. I have my inner voice is so disruptive that I have been trying to learn, I guess, mindfulness. I've been trying to meditate. I've been trying to learn how to sort of turn it off and just listen to the sounds around me, but it often just keeps coming back in. Annabelle has a question that's related back to, I think, one of Noah's points, saying, is that the same as schizophrenia? It wouldn't be the same as schizophrenia if Noah is controlling the monologue himself or knows that it isn't aliens. But in certain mental illnesses, there is that perception of the inner voice and also the belief that it is coming from some external being, or that maybe someone outside, out there, is putting the thoughts in their head, controlling the thoughts, maybe through microwaves or radio waves. The abnormal behavior that we see in mental illnesses or abnormal cognitions are just more extreme or intense versions of normal things, normal feelings and cognitions. So it's not true that thinking completely depends on language, but language does influence thinking. Okay, so the Sapir-Whorf linguistic relativity hypothesis suggests that the structure and the vocabulary of a particular language will actually influence or determine the overall perception and cognition of the native speakers of that specific language. So maybe there's things about the structure, the vocabulary of English that makes us likely to think in a certain way. Maybe that's different for other languages. And maybe some of you who are bilingual might have an opinion on that. But different languages do have different structures, different vocabulary. The German language has a lot of like ultra long words that express really complex ideas, like Schadenfreude, which is a certain kind of malicious glee you feel when somebody else is harmed. I'm back to seeing another question about a cousin whose inner monologue is different people at different times, and is that normal? If she's getting along okay and not in a psychiatric hospital, then yeah, it's normal. All right. So here is an example within a language of how words can affect thinking. In one experiment, it was by Elizabeth Loftus and colleagues, research participants saw a video where there was a car that two cars collided. Right? They watched that. Everyone watched the same video. And then afterwards, the researchers asked people to rate or to estimate the speed that the car was going at. But they asked the question in different ways to different people. So sometimes it said, well, you estimate the speed at which the cars bumped, hit, collided, smashed. And as you might expect, people's estimation of the speed, their memory of the speed, increased along with the kind of dramaticness of the language. And to the point that people who were asked how fast they were going when they smashed into each other, they misremembered broken glass at the scene that wasn't even there, that was never part of the video. So that's an example of how language does influence in this case, memory. You can imagine how important it is for forensic psychologists, for investigators, for detectives, for police to ask questions carefully and neutrally and not in a leading way. Imagine, let's say the police officer asks you how the suspect was dressed. Okay, we're not influencing your thinking there very much, just getting you to remember. But now, what if the police officer says, can you remember what color the suspect's jacket was? If you do that after people have been maybe watched a video where the suspect is not wearing a jacket, they'll misremember a jacket. Their mind will create the jacket that they remember. Children can be asked questions, like shown a doll and said, and where did the doctor touch you? And they'll touch the doll on places the doctor didn't touch. So leading questions are a big issue in forensic psychology and in investigations. There is a comment in the chat from a bilingual student who speaks 4 languages. Wow. Says that they feel like they almost have different personalities when operating in the different languages. That's amazing. Okay. Now we're on to decision making, which relies on thinking. As I've said before, you have a 2-track mind. You have your conscious track that can make very deliberate judgments, that can engage in a high level of analysis. And then you have those more unconscious processes, more automatic processes. Many of the decisions we make in a day are made implicitly, based on habit, based on schemas. When you came into this class for the first time, I didn't have to tell you what to do. You did what you learned you're supposed to do in classes, right? Find a seat, sit down, open your notebook, listen to me say things and take notes. You didn't reinvent that wheel. You applied a schema of what you're supposed to do in a class. While we make much better and less biased decisions when we think really critically and really analytically, you cannot get through the day doing that for every single decision. Right? That would just not be possible. And so we end up using these heuristics and schemas. And so overall, that's a good thing. Let me give you an example. Argument from authority. That is a logical fallacy, technically. Technically, something is true because it's true. Something isn't true because an authority figure said it is true. However, could you get through your day if you questioned everything every authority figure told you? In this class, you are acting on the assumption that I know what I'm talking about. And I think I'm pretty well prepared. And I think the textbook is pretty good. And I think I understand it pretty well. So most of the time, you're okay with that. But from time to time, I do make mistakes. And if you're applying that schema that everything I say is true because I'm the professor, well, you might learn something wrong. That'll probably happen. When you read your textbook, you're assuming that it's all true. A group of intro psych students in one of my other classes, when I talked about this, decided to start sort of fact-checking the textbook. So in the textbook, they'll make a statement, and then there's a reference. and the reference is to some paper, and that paper is listed in the references at the end of the textbook. And these students went and like looked at the statement and then looked up the original paper, and they found, I think in one session, 10 mistakes in the textbook where there was maybe some misinterpretation, some overstatement, or some issue of some kind. So think of all the mistakes that are in a textbook that thick. A lot. But you act on the assumption that it's true, and at the end of the day, you probably learned something half decent about psychology. You assume that your doctor knows what they're doing. And hopefully most of the time that's true. But if you've ever gotten really sick from a misdiagnosis or an inappropriate prescription, then you know that they do make mistakes. But trust your doctor and trust your professor is like generally a good rule. When we make decisions, we typically don't attend to all the information that is presented to us. Okay, we preferentially attend to certain kinds of information. And that's why framing is important. And the way you frame the same decision or the same issue can lead to totally different reactions and different decisions. A really simple example of framing is somebody, you probably heard this expression, seeing the glass is half empty and being an upset pessimist, and then somebody seeing the glass of half full and being a grateful optimist. Right? Different attitudes about the same thing. And the way we frame information can lead to different decisions. So if you're told that you have a 5% chance of winning something, would you be more likely to buy that raffle ticket than if a person said, you've got a 95% chance of losing? This reminds me of something I overheard somewhere. I can't remember if my mom said it or I overheard it in a convenience store, but somebody saying that, when they're buying a lottery ticket that, it was 50-50, right? Either you win or you lose. No, not the way probabilities work. Framing does have implications for mental health, especially around the way people frame kind of undesirable events or outcomes. So you could have something bad happen to you, and you could, using your framing skills, catastrophize it and awfulize it and make it out to be the end of the world and see it as shame and humiliation. Some people do that. Or you could frame whatever happened as learning. You could say, wow, I learned so much about myself from doing that. I learned about what I'm interested in and what I value. You could say, oh, I learned that there's some things that I need to do differently. Okay? You can fail well depending on how you frame that failure. You might have teachers that treat you very differently based on how they frame, let's say, poor performance or misdeeds. Okay, somebody could say, oh, you're a bad, lazy student, and they're gonna dock you marks or not let you hand something in. I don't know, punish you somehow. Or they could frame it in some sort of a developmental way and say, okay, this is where your skill level is at, and what do we need to do in order to support your success? What resources should we connect you to? Are there accommodations that you need? Those are totally different ways of framing, say, a performance issue. When we have bigger and more complicated ways of solving problems that would use, say, that conscious track, you could take a total step-by-step approach to solving a problem. And that will lead you to probably the right decision. Those are called algorithms. The book makes it sound like algorithms are just a thing that you can use all the time. For many problems that you encounter in life, there is no algorithm, right? Like there's not, maybe you're facing some situation that is unique, where there is no right way to do it. And you have to find your way through it. Generally speaking, there are some ways that we use or methods to solve new problems. So breaking something big up into little pieces might be one way to go about it. Or maybe you could draw an analogy between this problem and some other problem you faced before and try to implement a similar solution. We encounter obstacles and barriers with problem solving. The textbook talks about 3: the salience of surface similarities, mental sets, and functional fixedness. The salience of surface similarities issue refers to when, rather than focusing on the meaningful detail to solving the problem, you get distracted by something else. I'll give you an example of where I have used this in a trick question. Okay. I've historically used a series of questions. It's like maybe a series of about 5 multiple choice questions about research methods. They had an experiment. Like I describe an experiment and I ask questions about the experiment. And the first 4 questions are all research methods based, and that's what students are focusing on. And they're carrying that point over, that this is about research methods, from one question to the next question to the next question. The final question in the series is really an ethics question, and only about 10% of students get it right. And I'll ask that a question about the experiment, and there'll be some like details about the experiment. And I say, what should you do? And then some of the multiple choice response options are all about increasing experimental control in some way. And then the other option, which is the correct option, is, that you report it to, say, the department chair or the dean's office. And the students have been so focused on the research method stuff that they seem to forget that, or not notice that, this is a wildly unethical experiment. Okay, because they're seeing the surface similarity of the question as being a research methods question and not noticing that this is now an ethical question. Mental sets are when we get stuck in a schema. We have some kind of a schema that allows us to solve a problem, and it works, it's reinforced, so we keep using it. And that makes it harder to find other solutions which might be more efficient, or that in a certain situation might be the one that works. Take the example of somebody who has learned to restart their computer when something goes wrong. So since that's rewarded, now anytime they have some kind of a computer issue, they're going to reboot it. Maybe that's not the best way to solve the problem. And maybe it'd be faster if you, hit Control-Alt-Delete and closed some program that was causing the problem. But they don't do that because they're stuck in the set. Functional fixedness refers to a kind of mental set. It's about, the set is about how you use a certain object. You know that hammers are for, nails. And let's say that you don't have a hammer and you need to use something else. If you're totally functionally fixed in your thinking, you might not be able to think of something else you could use because you'd be using it in a different way. I will say, though, that I've used glass jars as hammers, and that's probably not the best idea. Here's an example of a mental set problem. And there's 3 examples here, but when this experiment was done with participants, they used more, right? Maybe it was like 5, maybe it was 10. So if you look at the first one, can you think of a way that you could fill a container with 100 mils of water just using these other containers? So just using those containers A, B, and C to fill the target with 100 mils of water, what would you do there? That too hard? Nick said 21 4 times. 21 times 4 is 84, and you need to get 100 in the bucket. You have to add some or take some out. So one easy way to do A would be like 127. You could put that in. And then take out 21. That leaves you with 106. And then take out 3 and take out another 3. Now you've got 100. Right. And then look, it works for this one too. You want to get to 72. Put 94 in, take out 20. Now you're down to 74. And take out a couple of ones. Now you're at 72. Once people have done that like 10 times and they've figured that's the formula, it's actually quite hard for them to get number 3 right, which Nicholas already figured out, but using the way he tried to solve A, which actually didn't work. So a much easier, the way to solve C is just 225s. That's harder for people to see once they've been coached into seeing that a certain way works. Every psychology textbook that I've taught from uses this experiment as an example of functional fixedness. And what they do is in the experiment is they ask you, well, how could you mount a candle to the wall using only the items that are shown here? And the correct answer, and this is supposed to be some kind of measure of, not being functionally fixed, is to figure out that you could do it by tacking the box to the wall and then using the box as the top of the box as a candle holder. I don't really understand why that is a specific test of functional fixedness. To me, I think this could be looking at some other construct, like, I don't know, creativity. Maybe it's a measure of fluid IQ. And there's evidence that throws the functional fixedness interpretation into doubt because the experiment was carried out in another culture, a much, let's say, simpler one, where people had very, very few tools. And so therefore they should have less functional fixedness, because they're not like, this tool does this one thing. It was a place where, you know, I don't know, people had one type of tool and used it for everything, but they had similar performance. So this can be questioned, this experiment, as a reflection of functional fixedness. Psychologists have sort of struggled to understand what the mind is. Historically, the mind has been the soul, and we moved away from that. The first psychologist, Wilhelm Wundt, redefined it as consciousness. But consciousness isn't your whole psyche. The advent of computers started coming out in the 1950s, getting way more developed in the 70s, then starting to enter people's homes in like the, I don't know, late 80s. Really influenced the way that psychologists thought about the mind. And psychologists started using computers as like an analogy for the mind. Do you think a computer... I'll ask you a different question. There are ways that our minds are similar to computers, right? We have memory. Our minds can have a conscious stream. That's kind of like a monitor displaying something. You input information into the mind. Okay, the analogy can go so far. Are there ways that your mind is different from a computer? Where would that analogy start to break down? I'd ask you a different question. If you guys have ever fooled around with chatbots, I used to do that. I used to think it was fun to talk to chatbots. This was like before ChatGPT, which is amazing, frankly. How do you know when you're talking to a chatbot? Let's say that I pretended to chat with you, but really it was powered by ChatGPT, and you're talking to ChatGPT instead of a human. How would you know? What could be a clue? Lack of emotion. Or like a really stable emotion. Like ChatGPT is always very agreeable. Easy to get along with ChatGPT. Yeah, they have a certain kind of robotic expression. They say things a certain way. That's how I know when students are cheating with ChatGPT. It just starts, it's the voice of ChatGPT rather than having a more individual voice. Keep repeating the same patterns over and over again. I keep seeing reflections by students about the rich tapestry of experience, because ChatGPT says that a lot. Yeah, they make fewer mistakes. That's true. Another big difference is context. Old chatbots were terrible at context. They couldn't remember like what you said before what you just said. And they would just lose the thread of the conversation. ChatGPT is an amazing advance, and ChatGPT is way better at context, and it can remember things from the previous conversation, but it can't remember things between conversations. And human minds are, textbook says, embodied. They're highly context dependent. We learn things and remember things in certain contexts. When you are in context A, the things you think about, the memories you have, the feelings you have are relevant to context A. And things you might do, thoughts you might have, memories you might have in context B are much less likely to come up. And we see this in memory studies. If somebody learns something in a particular context, they're more likely to remember it in the same context. If somebody learns something underwater, they're more likely to get the right answer when they're tested again underwater versus on land. You are more likely, you'll have a bit better test performance if you take your tests in the same place that you studied the material. And that connects back to the adaptive value of your mind. Your conscious mind is there to help you make decisions and navigate your environment, right? So you can better survive and reproduce. And it does that by giving you information, encoding information that's really relevant to particular contexts. So that's one way that we're different. I think that we can stop there, and next class we'll talk about language. I'll see you next class, and I'll stop the recording now.